this real quick. Okay, our objective is still to write equations in slope-intercept form and standard form from a given scenario. Ms. Wingrove's going to go over homework, and then we'll move on to the lesson. Ready for it? Okay. When you're done, just pound my desk. If you have questions, ask Ms. Wingrove, because I'll be teaching in a second.
Number 6. For the slope-intercept formulas. And then standard forming.
Does that make sense?
Right. Money depends on how many lunches you buy. I think that's what you're trying to say.
Yeah.
Money depends on the amount of lunches. X is lunches, Y is money. Slope intercept form teaching, what do you have?
Y is 1.5.
Almost. Somebody else has something different, Jared?
Maybe 1.5 x plus 12.
Right. So if you think of this like you have $12 in your wallet and you have to pay somebody $1.50. $1.50 for lunch. That's minus $1.50 every day that you have it. So it should be a negative 1.5. Standard form. Eric, what do you have?
3x plus 2y equals 24.
Okay. 3x plus 2y equals 24. That's the same thing like this. You add 3 over 2x to each side because it's negative. Everybody? Okay. Number 8, very last one. Brian B, what do you have? What over what? Not quite. Right. So your inches or height depends on the year. This is that every year you're gaining so many inches. So that means for inches depends on years. Does anybody else have it mixed up? Slope intercept form.
Y equals 5 x
that a little louder so everyone can hear you?
So make sure whenever you're doing this, don't put it into mixed numbers because then it'll mess up your search. Everybody thumbs up, thumbs up, thumbs up.
You did okay. Okay, thank you. Guys, just so I can make sure, I know you guys are fine on that, was the hardest part going from this form to this form? Just give me a head nod. Okay, were you okay with setting this up from a scenario? Give me a head nod. Okay, the important thing from that lesson was being able to set this up from a scenario. We still have a lot of practice built in going from this to this. We're going to work on that more today, and your homework tonight will be to go from both forms. Okay, part of it at least. Okay? Okay, I want you to open up your notes, or flip your notes, I should say, to page 5. Okay, page 5, which is the back of that homework, says components of a linear function at the top. We're not going to do all of these, so again, stay with me. This kind of talks about slope, y-intercept, and x-intercept a little bit more. And then the next page, which is 6, we're going to talk more about scenarios and standard form. Okay, homework will depend on how far we get, so let's see how things go. Okay, first thing, components of a linear function. You guys and girls know that you have a slope, a y-intercept, and an x-intercept. When you're graphing, you always have those 3 if it's linear. Okay, if it's a parabola, we had a lot of things. Okay, I want you to write where it says slope, which is the box below that. Slope is the rate of change between one quantity over another quantity. So slope is the rate of change between one quantity over another quantity. And I'm glad you guys brought up the thing about the decimals and mixed numbers. Make sure your slope is never a decimal. I'm actually going to add in here also no mixed numbers. You always want your slope to be rise over run, change in y over change in x. So no decimals, no mixed numbers. You always want your slope to be rise over run. And I think that was also part of the problem with some of the homework was you were trying to convert it or you were forgetting how to convert. Okay, who can remind us slope is always next to what variable or what letter when it's in slope-intercept form? What is the slope always right next to? Anastasia? Good. Slope is always next to x. That's something that at the end of the notes you probably would have figured out if you didn't remember that. But since you guys learned that last year, you should be fine. Okay, let's go to the first example. These are pretty easy, so we're just going to do a couple of these. Okay, they give us the same scenario from the previous page, but now instead of coming up with slope-intercept form, we just need to find the rate of change. In other words, what is the slope? Okay, so the scenario is Michael has run 3 miles this week and runs 2 miles every day. What is the rate of change, or what is the number that's changing? Anastasia? He already ran 3. Is that going to change? No, you can't change what you already ran, right? So this is going to be our rate of change. And I'll explain more. 2 miles every day. This is our rate of change because you're increasing this every day. So if I told you I'm going to run 2 miles every day, or we're all going to run 2 miles every day, the total amount of miles that you're running is changing as the day increases. So day is still x, miles is still y, that's not changing, but your rate of change or your slope is going to have these key words like every day, per month, each year. Any kind of key word that means you can repeat it, you can do it more often. Does that make sense? Okay, for slope, there's a couple things you need to write here. So let's start with this. You know from last year, slope is change in y over change in x. That's the first thing I want you to write down. Slope is change in y over change in x. In this problem, who can remind us what is the y? I told you, but who can remind us what's the y? Jared? Good. So y is the miles. I'm just going to put miles here for now. And what is the x? What is the x in this problem? Eric? Okay, so be specific, though. So is x miles or day? Okay. So from what we did yesterday, Y is miles, X is days. So you need to make sure you have the correct Y and correct X next. We're going to put in front of this 2 miles, okay, for every 1 day. Michael runs 2 miles every 1 day. All that I did, or had you guys tell me what to do from here to here, is change our fragment here of 2 miles every day to slope, which is our fraction, rise over run, or change in the Y over change in X, right? 2 miles is changing every 1 day, or it's increasing by that every 1 day. The last thing that we'll do for slope is just change it to a number. So your last step is just write it as a simplified fraction. Make sure you keep it as 2 over 1 or whatever the fraction might be. I don't know if I'm explaining that okay to you guys. Does that make sense, Brian? Yes, you have to do all 3. That's why I'm trying to be particular of how I do this with you guys. Yeah, you have to do all 3 things. After we get through the first 3 lessons here, you'll be able to do a complete graph problem by listing everything like this. Same thing with y-intercept when we get to it. Anyone else? Questions or comments? Okay, second one. Jen weighs 200 pounds and loses 3 pounds every week. Let me do this a little bit differently. Let's start here. Can someone tell me what is X and what is Y in this problem? Brianna. Okay, so pounds. What? Oh, wait. You said X is pounds? No. Sorry. Should say that again. I didn't mean to interrupt you. Okay, but give me a word. So between the weeks and the pounds. You know what I mean? Yeah, the X is the week. Sorry, you were giving me slope, I think. Was that what you were trying to tell me? Okay, I'll let you talk next time, my fault. X is week, Y is pounds, or weight lost, however you want to put that. So let's first identify X and Y. Okay, now let's go to what is the rate of change. Brianna, tell us what the rate of change is. Yeah, 3 pounds every week. So this is our rate of change. This is what's changing every week. Her weight is changing by 3 pounds. Okay, we need to translate that to slope. So we have change in Y over change in X. So why I changed my mind, I wanted you to list the X and Y first, is so that this would be easier. So change in Y means change in her weight or change in pounds, however you want to write that down, over change in X, which is change in weeks. Okay, so what number are we filling in next to pounds? So what number is going to go in front of pounds? Luke B. Nope. What's changing? Good. Is it going to be a positive 3 or a negative 3? Good. So her pounds are decreasing by 3 every what? Jared? Good. So negative 3 pounds for every 1 week. And then our last step is just to simplify this to negative 3 over 1. So change in Y over change in X. If it's decreasing, make sure it's negative 3 pounds for every 1 week. Our key word here was every. That's how you know that that is the rate of change. That's what's changing. Okay, let's go to 3. Okay, number 3. I want someone to tell us what's X and what's Y. So Mary owes $20 for her credit card bill and charges $5 to it each week. So what is the X variable? What's the Y variable? What does it represent? Anna? Okay, and do you want to do Y? You can do money. You could do bill. Doesn't matter. Or what she charges. It doesn't matter. So if you have something different, that's okay. There's a lot of different things you could put that would mean the same thing for the bill in this problem. Okay, go ahead, Brianna. Okay, then don't do that if that confuses you. Were you confused yesterday when I was having you write down what depends on what? Okay, so maybe you're confused with trying to figure out what X is and what Y is? Okay, but it's not. That's the $5 each week, that's the rate of change. That's not what X is. So let me back up then. Yes. Yes. So here's what you're doing, and I think Brian C, you're the same thing. You're trying to go right to the slope-intercept form, which is what we did yesterday. We now need to take a step back, and we're looking more specifically at slope. It's annoying, but we have to be able to write out every step for rate of change and then those three things for slope. And it starts with identifying what is x, which let me just clarify this for all of you. X is something you can't control. It's going to be your independent variable. Anything that deals with time, days, weeks, months, years is always x. Anything that you can control, as long as you're good with your money, you can control how much you charge on your credit card. Anything you can control is your dependent or y variable. Does that make a little more sense? Okay. Brian C, do you need to add anything to what she was saying? Because you were shaking your head like this. You sure? Okay. I know that your whole goal is for a month not to yell out, but you can ask questions. Sure? Did you guys know that? That's why Brian C's been sitting here so quietly. I'm just kidding, Brian. Okay. Anyone else have questions for me? Please, like you always do, tell me so I know before I keep going. Okay. Kyle, can you tell us what the rate of change is in this problem? Go back up a little. Good. $5 per week, or you could write what the problem says, which is $5 each week. You can either write it just like the problem says, or change it to $5 per week. Is everyone okay? I'm just going to slow down. Is everyone okay on why that is the rate of change? Okay, let's now go to slope. Our slope is going to be, did you finish, Brandon? Do you have a question? Okay, just making sure. Slope is always change in y over change in x. Is everyone okay on where that comes from? Why it's change in y over change in x? Give me a head nod this way or this way. Those of you that are not shaking your heads, are you not sure? Okay, let me just explain this a little bit. Remember the rise, if we go up or down first, your change in y is your y-axis. We're either going up or down first. Change in x is like your x-axis. You go to the right or to the left second. That's why it's always change in y over change in x. Okay, next part, let's label what our y is. We know that y is bill or money charged. We know x is weeks. Now here's what Brianna was saying is she just prefers to go right to this part, correct? With the numbers in it. Yes, you have to know how to do that, but you also need to be able to say as a fragment or as a sentence what the rate of change is. If you're charging $5 to your credit card bill every week, Gigi, should the 5 be positive or negative? Okay, good. Negative because you're charging it, so you're losing your money or you're spending your money. So it's negative $5 or negative 5 added onto your bill for every 1 week. And let me keep my dollar sign here. And then the last step, all you do is simplify that. So negative $5 for every 1. So just simplify it so it's just the numbers. Anastasia? Yes, it would be y equals negative 5x minus 20. Is that what you mean? You're thinking of the slope-intercept equation? Yeah, you're correct. But we're taking a step back from what we did yesterday. But you're right. And I think Will is the one that asked me that yesterday. If you have it as y equals 5x plus 20, you're fine. As long as you have them as both positives, because you're thinking of it as you're adding onto your credit card bill. That works. I think of it as negative because you're losing your money, you're spending money. Either way is fine. Anyone else? Okay, let's do one more together. Let's go to number 5. Skip 4. Let's go to number 5. Okay. Let me read the problem, then someone's going to tell us what x and y are. So don't go ahead of me, please. Number 5, Emily has $15 and loses 25 cents every day. Okay, I want you all to think about what x and y are and write them down. And I'm going to ask someone to tell us what they are. So write down what word is x and what word is y. What's the dependent? What's the independent? We're on number 5. So don't go ahead, just write down what you think x and y are. write down what X and Y? Oh, you did. Sorry. Luke, are you trying? You could try to write them down. Okay, you're thinking. Did you write them down, or are you thinking? I know. This. Do you understand why that's X though? Okay. It's weird. This chapter is very weird. I agree. Good. All right, Andy, can you tell us what X is? Good. Can you explain why? Do you know why? Or can you try to explain why is, okay. Can you explain why is the X day? I tried to explain this. Let's see if you guys can explain it back. Brian? Okay, you're right, but it's the independent variable. What did I try to say to you guys about X? X is something that, Anastasia? You cannot change that, right? We cannot change that today is Wednesday. Some of you are probably sitting there wishing it was Friday, right? You cannot control days. You can't control how many days are in a week. That is our independent variable, okay? Kyle, what's Y? Good. Money or money lost, however you want to think of that. This is something you can control. That is your dependent variable. You could also say here, money depends on what day it is, or the amount of money that you have depends on what day it is, okay? All right, Madison, what is the rate of change in this problem? Good, 25 cents every day. Your key word here is every day because that's what's changing. That's what's increasing or decreasing every day, okay? Let's go to slope now. First thing that we're going to write down for slope is change in Y over change in X, okay? We already discussed what Y was. So Y is money, X is day. So I'm just going to rewrite what the Y is and what the X is. And again, on your first quiz for this chapter, you will have to do this exact thing. I know this is very different than what we did last year with this, but it's just how this chapter is set up. You're going to plug in what goes in front of the money, which is we lost, or Emily lost, 25 cents per day. Since she lost it, it's a negative. Okay, so she lost 25 cents for every 1 day. So if you're losing it, it's negative. Brian V? We're getting to that, okay? Next thing, we need to convert 25 cents so it's a fraction. So let's convert it, Anna. Okay, 1/4. Now, when you convert it, you could say, you could still keep the words here and say, we lose $1 every 4 days. Does that work? If you lose 25 cents or a quarter every day, does that equal you lose $1 every 4 days? Yeah, it's the exact same thing. If you prefer to write this like this, that's fine. So again, 0.25, if you don't know how to do that in your head from last year, which you should, but if not, use your calculator, type in 0.25, hit math, enter, enter, and it converts it for you. Brian C? Sure? Anyone, please ask. Does anyone else have questions yet? Okay, and then once you get to this last step here, just change this so it's just a fraction, because when we graph it, we're going to graph this as -1/4. Start wherever, go down 1 to the right 4, down 1 to the right 4, etc. Brian V. Because then you'd have to go down 0.25 over 1. Down 0.25 over 1. It's not as exact as going down 1 to the right 4. Well, if we're talking about money, yes, but you can. There's nothing wrong with doing that, but it's just not going to be as exact. You know what I mean? There's nothing wrong, but to me, Brian V, it's really hard for me to use my eyes and figure out how far 0.25 is down. When you're just going down 1 to the right 4, that's much easier because you actually have a nice spot to land on the graph. You sure? Anyone else? Okay. I want you guys to try number 6 and 7. Yeah, try 6 and 7. When you're done, put your pencil down. So the first thing I want you to do is label what X is and what Y is, and then do exactly what I did on the board. I will leave number 5 up so you can see the order that we did things. Ask yourself what X is, what Y is, set it up just like we did. I will go over them, so take your time. So make sure you guys label what X and Y are. Okay, I just want you to try to label what X and Y are. You're doing a good job there, but also label what X and Y are. Okay, you guys look like you're doing much better now. You okay? Good. Just 6 and 7. Just do 6 and 7, guys and girls. Just look, you can keep going. Good. Very good, Alina. Doing a little better. A little bit. What's still confusing you?
I just don't get this whole thing.
Like why we're doing it this way?
Yeah.
Okay. What about this? Let's go backwards. Are you okay with identifying what X and Y are?
Yeah.
Okay. Okay. There, I'll get to that. Doing okay? Sure. Doing okay? Sure. I don't know. It's hard to read your writing. The rate of change you need to make sure you write down 0.75 miles every day. No, I'm just going to see if this helps some of you because there's one more thing I think that you guys need cleared up. Okay, finish up what you're on. I'm going to try to clear up that one extra thing I think some of you guys are still struggling with. Okay, number 6. Eric, can you tell us what you thought X was in number 6? Good. X is day. Kevin, can you tell us what you think Y is in number 6? Good. So X is day, Y is mile. Anyone need me to explain that any further? Okay, so that you guys can see the future, once you identify what X and Y are, here's what you're going to do. On your graph, you have to then label, okay, the X-axis refers to day, the Y-axis refers to miles. So that's one reason why you have to do that, okay? Independent, dependent. Independent, dependent. Okay, so you with me? That's the first step. On the Keystone exam, one reason why we changed this chapter, they have you do this. You have to know how to label axes on a graph. Okay? All right, next thing, what is the rate of change? So pulling it from this problem just by saying it. Brianna, what's the rate of change? Good, 0.75 miles per day or every day. Okay, your key word there for rate of change is every. Why do you need to write down what the rate of change is? Standardized exams, later on in math, they might say to you, well, not what is the slope, they might say to you, what is the rate of change? The rate of change is the exact same thing as slope. They are identical. There is nothing different about these besides how you're writing them. Okay, so this rate of change is the exact same as slope. All right, let's go to slope. So why are we writing this as change of y over change of x? Let me go back to that part. Did I show you this last year? I think I showed it to you, but I know it was a while ago, but I didn't explain it as much as we're talking about today. Change in y means, ready? Rise is the y-axis. Run, which is this way, is your x-axis. The reason it's change in y over change in x is because of your rise over run. This means the exact same thing as rise over run. Give me a head nod. Does that make any sense? Anastasia, that doesn't make me feel confident. Okay, give me a reason why, so that your nod can be like this instead of. Okay, but you get this and you get this. Okay, so is it this part of the slope that you're confused on? Not the part where we have to write it out, right? Okay. Is anyone else feeling the same way? Or you're not sure? Okay, let me go back one more second. So let's go back to this. You guys all remember from last year, rise over run, right? Okay, go ahead, Brian. Yes, don't change your notes. Yes, I'm just doing this just to try to explain a little further. So rise over run, when we graph something, let's just pretend like we have to start here. And if your slope is positive, you go, let's say we started here. Your rise goes this way, your run goes this way. That's if our slope is positive, okay? So, Anastasia, you with me? And I'm not just focusing on you, it's for everyone, okay? I'm just using your head nod. Rise over run, rise over run. The change in y, which is the rise, means it's the change in y values. So technically, if you guys think back to the slope formula from last year, remember y2 minus y1 over x2 minus x1? Give me a head nod this way or this way. Do you remember that from slope? y2 minus y1 is the same thing as the rise or change in y is because you're subtracting the distance from here to here. That's what change in y means. Are you following that? Okay. This way, which is your run, is change in x. That is the change in x values. You're taking x2 minus x1. Okay. I'm going to stop explaining that there, just going that far. We're building on things. We're getting to the slope formula eventually. I think that you guys are used to the chapters being, okay, here's a formula, let's solve it. The whole understanding of it is going to come a little bit at a time. We're going to get more into slope once we actually start graphing scenarios. Okay? So let's finish this, and then I'll see if there's any other questions. Okay, so Brian C., I want you to tell us, after you wrote down change in y over change in x, what goes next to y, or next to this change in the numerator? Okay, so first, change in miles over change in day. I'm sorry, then say that one more time. I want you to for now. Yes? What number did you have next to miles, and what number did you have next to days? Okay. For every 1.50 for every 1 day. Yeah, I'm like, wait a second, where's this coming from? Yep, so was I. Both of us are looking at the wrong problem. So 0.75 miles, sorry guys, for every 1 day. So your next step is plug the numbers in, write it down. Jared, what fraction did you convert 0.75 to? Good. So 3 miles for every 4 days. So is that true? Is running 3 miles every 4 days the same as 0.75 miles every 1 day? Yeah, same thing. Last step is change that to just 3/4. So one more time, once you have your slope, obviously we have to find our starting point. That'll be in a couple days lesson. Start wherever. Your change in y over change in x would be up 3 to the right 4. Up 3 to the right 4. Luke. Yep, we're getting there. This chapter is very different for me too, but we're getting to that. Yeah. Anyone else? Okay, the last one, Kyle, what did you put for your x and what did you put for your y? Good. Okay, Nathan, what is your rate of change? Good, so $1.50 each day. That is what's changing. That is your rate of change. Madison, what is, don't tell me the change in y over change in x part, tell me the next part with the numbers and words. Both. The second part, go ahead. Good, so $1.50 for every what? Good job. And then we need to convert that. So, Alina, what is your fraction? Oh, fraction. Did you change 1.50 to an improper fraction? Okay, you need to do that. If you're not sure, use your calculator, type in 1.5, hit math, enter, enter. Eric, what did you change 1.5 to? Negative $3 for every 2 days. Or you're spending $3 every 2 days. Okay, any questions for me? We're going to do more of this tomorrow. Sure? Okay, I need you to open up your homework packet to 3-8. I didn't say you wouldn't have homework today. I didn't say that. I said the homework depends on how far we get. I thought that's what I said. Is that what I said? All right, practice 3.8. It's not a lot. Hold on. Listen, practice 3.8. It's page 63. Okay, I want you guys and girls, now listen, you need to do numbers 1 through 6. But hold on, I'm going to change the directions a little. You need to write it in slope-intercept form. Practice 3.8, it's page 63, Brian. Okay, you're only doing 6 problems. Sit down, because you need to do your homework. You need to do it both forms, slope-intercept and standard form. I will do more practice with you with that lesson tomorrow, and then we'll move on. Okay? All right, have a good day. Thank you. Are you a little better or no? Sorry.